So today I'm going to show you how to do 6.5 graphing trig functions. We're going to be working with cosine since it's a little more complicated, and we can start by looking, not in our textbook because I'm actually modifying an example in your textbook for you today, but let's start by looking at the basic model of a cosine graph. So the equation is y equals cosine theta. Theta is your angle value. And this is your basic graph. So what we have are several elements. First, let's start with amplitude. Amplitude is the distance between each part of your graph. So the top part and the bottom part. Each graph is set up in curves that look like this. And the top half and the bottom half each have amplitude. Amplitude is how far up or down they go, how far they extend. So in this case, the graph extends up to 1 and down to -1. So 1 is your amplitude. Now, when looking at the graph, we see that it goes from 0 to 2 pi. That's your period. The period is how long your graph takes to complete one cycle. So this is an entire cycle. It's an entire top curve and entire bottom curve. If you see these two pieces fit together, they would make one solid curve like that. So that is your period, and your phase shift is how far left or right your graph is. Right now this is centered. This is traditional standard setting for cosine. So we're going to start up with our maximums at 1 and 2 pi, and our minimum is at pi on the graph. So it's at -1, but it occurs when theta is pi. So now that we've seen the basic model for a cosine graph, also we can move this graph up or down. So if we added something to the end of this equation, then the graph would move up or down accordingly. However, we're not going to do that right now. So I am working out of Advanced Mathematical Concepts by Glencoe and Harcourt, and this is on page 379. However, I'm taking example 1b and I'm modifying it so that we can get all the different types of change you could in a graph, and you can see how that all works together. So let's start by writing the equation. We're going to have y equals 3 cosine 2 pi minus pi over 2 plus 4. This is the most damage you could possibly do to a cosine graph. So we're going to move it up, down, and all around. And so what we're going to start with is our different elements of this equation. So let's look at this 3 right here. 3 is going to be your amplitude. I'm going to write all these different vocab words over here. So amplitude. How far is between this point and this point in your graph? Amplitude is 3. Amplitude is always going to be the number right in front of your graph. So don't worry about that has to be changed or we have to solve for that. It's just right there. And then we're going to have a phase shift. A phase shift is, do we move it left or do we move it right, or does it stay still? And we actually do have a phase shift in this graph, and we'll find that soon. So I'm going to write phase shift over here. Okay, and then we have a change in period for the function, and don't worry, all this will be explained because that you do have to modify a little. So your period is going to be another vocabulary word. And last but not least, we have a vertical phase shift. So I'm going to write H over here because that's horizontal, but our vertical phase shift is going to deal with this number over here, this 4. And so the vertical phase shift is what it looks like. You take the number that you see here, and if it's a plus, you move the graph up 4 units, and if it's a minus, you move the graph down however many units you see here. So in this case, we're moving the graph up 4 units. So vertical phase shift is going to be plus 4. Okay, great. So now that we have all of our vocabulary here written on the side, let's start with finding the horizontal phase shift of our equation. So, in order to find our horizontal phase shift, we are dealing with the variables C and K. C and K are found on the inside.
Ms. Hoffenick, can you come to the main?
Okay, we are going to be dealing with the variables C and K. C and K can be found inside your equation right here, in this parentheses part. C over K is your horizontal phase shift. HPS. So when we have a horizontal phase shift, our C value is going to be this right here, this part of our parentheses. Disregard the minus for right now. This is going to be our K value, and that has to do with period, which we'll find out later on. So C over K equals horizontal phase shift. So we have pi over 2 over 2, and that will get us pi over 4. So how far are we moving, left or right? We're moving pi over 4 units. Now, since it's a minus inside, if you remember from the PowerPoint, we're going to be moving to the right. So whenever it's a subtract, you move to the right, and whenever it's an add, you move to the left. So how far do we move? Pi over 4 to the right. So we're going to go ahead and write that under our vocab over here. Pi over 4 to right. That means this curve is going to shift that way. Now let's find our period. Our period in the equation is going to be dealing with this K value, which we see right here. So K is the amount that your graph expands or contracts. So this is going to either get wider or it's going to get more crunched together, and is going to determine how long it takes for the graph to complete one entire cycle. So once the graph completes an entire cycle, that value is how long your period is. So y equals cosine 2 theta is changed from our original equation, y equals cosine theta. So in order to determine the change in period of the graph, Victoria is going to have to pause the tape. So now we're going to be working with the period of the function. The period of the function is found by doing 2 pi divided by k. Ironically, in this situation, k is 2. K is the coefficient of theta in this equation. So if we do, and why do we do 2 pi divided by k? Well, let me show you. In the original equation, 2 pi is how long the period is. So that's what it takes for a normal cosine to go through it. So if you have 2 pi and you divide it by the coefficient in front, that will give you how long your new equation takes to complete one entire cycle. So 2 pi divided by k equals, in our case, 2 pi divided by 2, because 2 is our k value. And that cancels out the 2's, and your period equals pi. So what does that mean? It means that our equation will have one complete cycle by the time it hits pi. So in other words, it goes twice as fast. 2 twice as fast. Now, let's say it was 1/2. Then it would go twice as slow. So now we're going to graph our entire equation now that we have all the vocab down. And I will go ahead and draw that graph for you. So let's put up our original equation again. Y equals 3 cosine 2 pi minus pi over 2 plus 4. So we start with our big graph. Okay? And we know that we have moved our midline, which is the center of the curves, the center of the two curves, which in this case is the x-axis. It's right in the middle vertically. So we have moved our midline up by 4. We have a phase shift of 4. So that means I'm going to go up 4 units. Actually, you know what? That's not going to work very well. I'm going to go up 4 units in my graph and put my midline there. So 1, 2, 3, 4. This is where my midline is going to be. And I'm going to draw that for you in red. And then I'm going to continue 5, 6, 7, 8. So that we have equal spacing. So now that we have determined where our midline is, next step is amplitude. How far up or down does our graph go? Well, we said it was 3, right? So amplitude, according to our vocabulary list, is 3. That means that our bell curve is going to hit peaks at 3 above the midline and 3 below the midline. So 3 above the midline, what is 3 above 4? It's 7. So 1, 2, 3, 4, 5, 6, 7. Let's just go ahead and put a little star right there. And 3 below the midline is going to be 1. So 1, 2, 3, put a little star there. And that is how far, this is the range of our graph right here. So when asked the range of this function, you will successfully be able to answer 1 to 7. Because we go from 1 to 7. Okay, so now that we have our amplitude down, we are going to have to graph the rest of the function, this phase shift and the period. So our cycle ends at pi, which is what we said because it goes twice as fast as the normal equation. So pi we can put over here at the end, right? Because that'll make things easy for us. So if you see pi here, that's where our graph is going to end. And we are doing, now we have to focus on the phase shift. So phase shift moves the bell curve over. When we have different parts of our graph, we know that this bell curve is going to have an up and a down. Now whether it's divided like this or whether it looks like this depends on how far left or right we move it. So we've decided to move it right by pi over 4, which means that the center of the graph is going to move by pi over 4 to the right. So let's start by dividing these in equal parts because we know that we have to have a halfway point. What is pi? What is half of pi? It's pi over 2, correct? And what is half of pi over 2? Pi over 4. And what is in between pi over 2 and pi? 3 pi over 4. So these are the different, this is our graph broken down into equal little divisor sections. Now, if our graph originally starts here at 0, at its maximum, and we now move it pi over 4 to the right, where is our maximum now going to be? It's going to be at pi over 4. So let's put a little point there because we know that's where our maximum is going to be. Now if our minimum originally started at pi over 2 and we have to move it pi over 4 units, we're going to move our minimum from here to here. No. We are going to move our minimum, our minimum was originally at halfway, which is pi over 2. Now we're going to move it to 3 pi over 4. Do you see how that happened? So basically what we did is if we originally started here for the maximum, we moved it pi over 4. And if we started here for the minimum, we moved it again pi over 4. So now our maximum is at pi over 4 and 3 pi over 4 is our minimum. Now all we have to do is draw in our curves. So that is the easiest part of this little equation here. We know that we have to go up to 3 and here's the maximum and we have to have a halfway point. So where is this graph going to hit our midline? It's going to hit in between the max and the min, right here at pi over 2. So now this is going to look suspiciously like what kind of graph? Like a sine graph. So if you move a cosine by pi over 4, you're going to get some form of it's going to look like a sine graph, even if it's cosine. So now, we start here at our midline. We go up, we hit the maximum. Then we go down, we hit the halfway point. We go down, we hit the minimum, and we come back up and hit the midline. And voila, that is how you have graphed this entire change of our cosine graph. And remember, even if it does look like sine, it's still a cosine. You just moved it pi over 4 to the right. And that's it.